Okay, here we go. This is the first. This is the first thing that's going to be on the final. This is section 3.1 to 3.4. So let's go through this. It's been a while since we've done this stuff, so this should be a good review for you. Hopefully, you're watching this. Find the midpoint. Let's do midpoint. Okay, the midpoint. Remember, it's a point, so it's an ordered pair. So what you do is you add up the x's divided by 2, and then you add up the y's and divided by 2. So this is your x1, y1, this is your x2, y2. So you just put the points in here, add up the x's. So it's 9 plus negative 5, or 9 minus 5, however you want to write it. Divide that by 2. Remember, this is an ordered pair. Then you take the two y's and you add those together. So that's negative 5 plus 1. Divide that by 2. Now you just work it out. 9 minus 5 is 4 divided by 2. Negative 5 plus 1 is negative 4 divided by 2. Just simplify it. 4 divided by 2 is 2. Negative 4 over 2 is negative 2. And that would be your midpoint between those 2 points. Alright, these two problems actually have to do with distance formula. Might not look like it, but remember, if we decide if they're a right triangle, remember what has to happen. Oh, there I go again. Messing up my marker. Let me try it. Let me just do a quick fix here without turning it off. You can't see what I'm doing. I'm just changing the pen so it works right. Okay, so here we go. Let's call these. Well, let's talk about this first to see if it's a vertice or vertex, the vertices of a right triangle. Let's determine what makes a right triangle. Well, if I go c squared equals a squared plus b squared, then it's a right triangle. C represents the longest side, and A and B represent the other two sides, the two shorter sides. So what we're going to do is we've got to find the distances between all three sides. Remember, this makes a triangle. I'm not going to draw it out, but let's just call this point A, call this point B, and call this point C, for lack of a better way to do this. So now we've got three sides. We've got side AB, we've got side BC, and we have side AC. So let's find the distance between those three sides. We're going to take the longest distance. Once we get all three distances, we're going to take the longest one, we're going to square it. Then we're going to compare it to the distances of the two smaller ones, squared and added up, and then we're going to see if that is true. If this is true right here, then it's a right triangle. You'll see what I'm talking about once I get started. So let's find the distance between A and B. If you remember what the distance formula is, oh my, that's a terrible square root. That's okay. What we're going to do is we're going to subtract. Let's just write the distance formula here. So it's alright. So it's going to be, you're going to subtract the x's this time. They're going to square them. Basically, what it is Pythagorean theorem. Then you're going to subtract the y's and square those, add them up, put them under square root, and that's your distance formula. So let's put them in here. So let's subtract the x's. So it's going to be negative 4 minus 2. We're going to square that. And then we're going to go 8 minus 10. Square that. Let's just write across like this. So this is what? Negative 6. We'll just write it in here. Negative 6 squared. And then this is going to be negative 2 squared. Negative 6 squared is 36. And then this is going to be positive 4. And we'll just leave it like that. Really no sense in changing it to a simplified radical. So it's a square root of 40. Now we're going to take a look at, let's go BC. So let's see the distance between BC. Once you know this distance formula, it's really not that hard to do. I like to do this first. Put my parentheses in my square. Then all I got to do is put my x's in there, my y's in here, subtract them. So again, we're going between B and C right here. So 2 and 1 are my x's, so 2 minus 1. My y's are 10 and 5, so I go 10 minus 5. Let's figure out what that is. Square root. That's 1 squared, and this is 5 squared. Alright, that's square root. Let's figure out what that is. That's 1 plus 25, and that would be the square root of 26. Alright, that's BC. Now let's do AC. That's the third side. Doesn't matter what order you go in. Alright, square root. Again, I like to set it up, just putting my two parentheses here with the squareds on the outside. Now we're doing AC, negative 4 and 1. So it's negative 4 minus 1, and we're doing the y's, 8 minus 5. You can do some of this in your head. I'm just showing you all the steps. Alright, so negative 4 minus 5 is, I'm sorry, negative 4 minus 1 is negative 5. Got ahead of myself. and then 8 minus 5 is 3. We square that. If you square negative 5, you get 25. You square 3, you get a 9. Take the square root of that, and that's 34. There you go. Now what we're trying to do is we're trying to see if it's a right triangle. So let's see if it fits right here. Take C is the longest side. Which one is the longest side here? It's the square root of 40. So the square root of 40, and what do we do to it? We square it. Now we compare it to the two smaller ones, squared and added up. So this is the square root of 26 squared plus the square root of 34 squared. Let's see what we get. That's when you square a square root, that just goes. That's just 40. This is 26, and that's 34. Do they equal each other? Obviously not. Watch that. That's 50. That's 60 right there. Of course, they don't equal each other, so this is not a right triangle. So just say no. A lot of work just to say no, but you have to go through that to make sure that you know if it's a right triangle or not. This next problem is very similar. We're still going to find the distance between all 3 points, but we want to see if it's collinear. Remember, if it's collinear, watch, if this is A, B, and C, AB, right, plus BC must equal AC. So this is what we're looking for. We're not squaring them. We're just seeing if the two smaller sides add up to be the longest side. And if they do, then they lie along the same line, which means they're collinear. Alright, let's get right to it. We can probably skip a few little steps that we wrote all down for the last one, since we've seen this distance formula a lot. Again, let's just call it A, B, and C. Make it easy. Now we're not sure which one's the longest and all that kind of stuff. We don't even have to graph it. Let's just take the two sides. We'll pair them all up, figure out what the lengths of the sides are. So let's just do AB again. So it's a square root distance formula. I'll put this stuff in here. That's supposed to be a 2 for squared. Right there. Alright, subtract the x's from each other. So it's negative 3 minus 2. Subtract the y's from each other. It's negative 7 minus 3. Let's see what we get. Negative 3 minus 2 is negative 5. Squared is 25. This is negative 10. Squared is 100. And then take the square root of that, and that's the square root of 125. We'll just keep it like that for now. Let's do BC. After this point, you should really have the distance formula down pat. Subtract the, we're doing BC from here to here. So it's 2 and 5, so it's 2 minus 5. And it really doesn't matter what order you subtract them in, because you're going to square them anyway. Then it's going to be 3 minus 9, square root. And that's negative 3 squared is 9. And this is negative 3 squared. I'm sorry, negative 6 squared, which is 36. And that's the square root of 45. And then now let's do AC. Alright, so set up the same old thing. Parentheses squared, parentheses squared. Subtract the x's. Now we're doing AC, so it's negative 3 and 5. It's minus, so it's negative 3 minus 5. And then it's negative 7 minus 9. Alright, let's see what we get there. Negative 3 minus 5 is negative 8 squared, which is 64. And then plus, this is negative 16 squared. I don't know what that is. Let me get a calculator. Okay, so 16 squared is 256. I should have remembered that. Just a little brain freeze. So 256 and 64. Let's just add that real quick here. 64, and that's 320. So that's 320, but again, it's under a square root. Now, what we have to do is we got to compare them. Take the longest side, which is the square root of 320. We know that's the largest one. And let's see. I'm going to put a question mark here because we're not sure if they're going to be equal to each other or not. Now, do we just add up the things inside the square root? No, because we can't. Because they're not being squared, so the square roots don't really go. So what we're going to have to do is compare these and see what we get. Calculator would be helpful here. I can't do that in my head for sure, so let's do that. Let's go square root. That'd be second function right there. Oops. Let's do it like this. Let's go second function. Alright, there we go. Alright, so that's the square root of 320. And let's see what we get. That's about 17.88. It's close enough. Alright. And we can just do all this in one shot right here. The square root of 125. So let's go square root of 125, and then you add it. Actually, I don't know if you need a parentheses or not. For some reason, I just kind of like to put it there. So you add it to the square root, second function, of 45. All right, close that. Set it equal to each other and check it out. That's the same exact number, isn't it? 17.88. That's what we have right here. And they're equal to each other, so yes, they are collinear. They lie on the same line.